line and ask to find the gradient of it, sometimes they will just tell you 2 coordinates. Now, obviously, you do have the option of drawing yourself to that T, plotting those 2 coordinates, and drawing your line and then counting the rise over run. But quite frankly, that's ridiculously long, and so we want to avoid doing that wherever possible. So do you remember when we were looking at the length of the line, and we had the rise and the run, we were doing the change in y over the change in x, do you remember that?
Yes.
Yes, no, good route. When we set ourselves Pythagoras' theorem, I can't say what. Alright, so do you remember how we were given 2 coordinates? Alright, so going back to when we had the length of the line, we were talking about coordinates, yes? Yes? And we're going to use the same kind of principle as we did when we were trying to find the length of the line when we're finding the gradient. Because we know that the gradient is the rise, which is this red bit, divided by the run. Yes? Do we recall how we found the length of that line? Do we remember how we found this length here? What do we do? This one here. Okay, so that was y2 minus y1. Remember that was these were the y coordinates, yes? And so that was y2 minus y1. And how would you define this blue next? x2 minus x1, yes? So the same kind of principle is going to happen here. And if we're trying to find the gradient, we would try and find the red length, and we would divide by the blue length, yes? So it's going to be y2 subtract y1 divided by x2 subtract x1. If we go here, you'll see this stuff we're getting here. Now you do not get given that, so you do need to learn it. But to be honest, I'm hoping that it kind of makes sense to you, because we know that our rise talks about our y coordinates, yes? That's on the y-axis. And our run will be our x-axis, because they're the ones that go across. So if you always remember that gradient is rise over run, it will help you remember which, order they go. Yeah? Now, the gradient is generally known as m. Okay, so I don't know why they use m. Zero idea, don't really catch on it. But generally they use m for gradient. So m represents the gradient. I don't know why G. I think probably because it represents grams. So it's m. Okay. So m represents the gradient, and that's rise over run, which is y2 minus y1 over x2 minus x1. It's advisable, as I said, to label the coordinates the same way we did it when we did length of line. So we're asking to find the gradient of the line joining 3, -1 and 2, 5. Remember, it doesn't matter which one's which. If you want to call this one x1, y1, you can. Otherwise, x1, y1, x2, y2. So my gradient is going to be 5 subtract -1 over 2 subtract 3. So my y2 subtracts my y1, and my x2 subtracts my x1. Be careful with your negative signs. Here we've got 5 subtract negative, so when we are taking away a negative, it becomes plus, so that's going to be 6, and 2 subtract 3 is -1. 6 divided by -1 is -6. So this is a negative gradient, quite steep. End of question. Okay, so it's pretty straightforward. You just need to make sure that you're remembering to subtract the y coordinates on the top and the x on the bottom. No. No. Okay. So. Oh, this is Ow! Alright, okay, so parallel lines. Parallel lines are lines that are always the same distance apart. Okay? Now, we do not say that parallel lines are lines that never touch. That is not the definition of them. Parallel lines are lines that always are the same distance apart. So please try and get out of your head they don't meet. They won't meet. However, the definition of them. Alright, so parallel lines are the same distance apart. They also will always have the same gradient. Okay, we would see that our rise over our run would be the same for each of them. So parallel lines have the same gradient. Perpendicular lines meet at 90 degrees. You understand? You know what perpendicular means? Yes? So they're meeting at 90 degrees. So if I had a line here, a perpendicular line would meet it like that, and at 90 degrees. So perpendicular lines meet at 90 degrees. They have what we call negative reciprocal gradients. Now, do we know what reciprocal is? Okay. The fraction has been switched around. Flipped upside down, yes? And it's the negative reciprocal. So actually we flip it upside down and we change the sign of it. What happens then is if you were to multiply those two gradients together, you would always get -1 as your answer. So perpendicular gradients always have to multiply to give -1. So if one of our gradients was 3/4, the perpendicular gradient would be -4/3. Yes, so we flip it so it becomes 4/3 instead of 3/4, and we change the sign.
Where's the negative?
Because it's the negative reciprocal.
Okay, so you'll just put that.
So you all not always you change the sign of it. Okay? We're going to do one here now. We're going to do one here now. So if the gradient was -5, we remember that a whole number would be 5/1, yes? So its perpendicular gradient would now be +1/5. Yeah? You happy with that? Yeah. So you change the sign of it. So if one was negative, the other will be positive. And it makes sense looking at our diagram here. This one was uphill sloping, this one has to be downhill sloping. Yes, so if one is positive, the other has to be negative. Okay? So using facts about parallel and perpendicular lines allows us more scope when asking questions using the gradient formula. So if we're to find A, if the line joining P and Q is parallel to a line of gradient 4. Okay? So this is 1, 3, and this is 3A. So we know that if something is parallel to a line of gradient 4, I know that my gradient of PQ has to equal 4. You understand that? So if let's start back again. If we were to find the gradient of these 2 points, let's use our gradient formula. So how would I find the gradient? We have to use the letter A because we haven't got a choice. So if I were to find my gradient, what would I write? A minus 3 over 3 minus 1. That would be how we would find the gradient, yes? So y2 minus y1 over x2 minus x1. Well, if our gradient of that line is parallel to a line of gradient 4, it means the answer to this has to be 4. Oh, because parallel lines have equal gradients. Yeah, make sense? So what we can do now is we can simplify this. So we've got a subtract 3 over 2. A subtract 3 all divided by 2. We would multiply both sides by 2 to get 8. And then add 3 to both sides to get 11. So we found the value of A is 11. Yes? So find T given that the line joining points A and B is perpendicular to one of gradient 1.5. Okay, so we've got our two coordinates. Label them x1, y1, x2, y2 if you wish. We know that it's perpendicular to a gradient of 1.5. Now, 1.5 is not helpful, so we want to write that as an improper fraction. We're good at doing that because we learn all about fractions. So 1.5 is what?
3 over 2.
Or secretly 3 over 2, so we said 2 over 1. Okay, so 1.5 is 3 over 2. So the value of n in our example has to be its negative reciprocal. Why are we looking for the negative reciprocal, Kirsty? But why are we finding a negative reciprocal? What do we know about our two lines? Not the same amount. Well, in the question, what information did they tell us? We know that our lines are perpendicular. So if lines are perpendicular, it means that the gradients are going to be the negative reciprocal. So we know that our gradient we're looking for is negative 2 over 3. Yes? You're happy with that?
The negative sign just came. But how did we know the negative sign was on 3 to start?
Oh, no, we didn't. Remember, the first one was positive 3 over 2. So our negative reciprocal was negative 2 over 3.
Why don't you put the negative sign looking at the side?
Because we never have negatives on the bottom. It's either in the front or the top. I think we just had it.
Yeah, but we did have it on the you might have one over negative 5.
Push it back. Wait, I didn't want you to write that.
Wait, no, it makes sense. Yes, it was negative 5 over.
So in the previous example, we set our equation up and we equated that to 4. We equated it to 4 because we knew that they were parallel lines and that the gradient had been 4. For this one, we're going to set our equation up, and this time we're going to equate it to negative 2 over 3 because that's the perpendicular gradient. So setting our equation up, we're labeling y2 minus y1 over x2 minus x1. So we've got t subtract negative 3 over negative 2 subtract 1. You all happy with that? So that's going to be equal to negative 2 over 3. Now, it's at this point, generally people say, well, what's negative? Is that they both negative? No, you pick one of them to be negative. So this is where you will only have it with one of the numbers. You can choose which one. Normally, I would keep it with the top number. So it would be negative 2 over 3. You've got choices here as how you solve this. Okay? You can cross multiply if you're more comfortable with that. You can simply multiply by the denominator, both sides by the denominator over here. You're going to be multiplying a fraction by that denominator, that's fine. However you solve it, I don't mind.
Negative be on the same line as the conclusion.
So when we are writing fractions, it's either just in front of the fraction or on the top. In this case, you probably want to assign it to one of the numbers because it'll help you with your cross multiplying. Yeah?
What's the point of like going further than minus 2 and 3? Because I thought that was against.
No, don't remember we have to find t. But in the previous example, we were just able to equate it to 4 because the lines were parallel. In this question, it's perpendicular to something with a gradient of 1.5.
Oh.
So we couldn't just put it equal to 1.5. We had to put it equal to its negative reciprocal. Yeah. Yeah, that's what we're going to do next. Yeah, so now we can start simplifying and sorting this out. So we can change this to be t plus 3 because we're taking away a negative value. You've got negative 2 subtract 1 is negative 3. equals negative 2 over 3. So it's at this point, if you don't like multiplying fractions by anything, you can cross multiply. You're actually making life hard for yourself if you do. I would probably just do this. So I've got negative 2/3 multiplied by negative 3. So I'm multiplying both sides by negative 3. Okay, so we've got t plus 3 equals, I can see that these cancel. So I've just got positive 2. And then t is negative 1.